So we're on lesson 4243. This is the first day of it, so I have to teach you a lot of basics and do some examples. We are not going to finish these notes. We'll finish them tomorrow when we're all together, or whatever day I see you, whenever we're all together. On Friday, I talked to you about congruence of polygons. And so we learned that polygons or any shape were congruent if all of the corresponding angles were congruent and if all of the sides were congruent. If that's a triangle, that's 6 pieces of information we need. So we need all 3 sides and all 3 angles. Okay, I'm about to teach you 5 shortcuts that don't need 6 pieces of information. They just need 3. But before we get there, let's go to our third angle theorem and let's remember what's going on there. So our third angle theorem says if these 2 angles are congruent and if these 2 angles are congruent, and let's label these A and B, then that means that A and B must be congruent because the 2 angles in both of the other triangles are congruent, so the third angles must also be congruent. 1, 2, 3, 1, 2, 3, and I'd write angle A is congruent to angle B. All right, that's third angle theorem. The reason we're remembering that is because I want to know if having all 3 angles congruent, if doing third angle theorem proves my triangles are congruent. Now, we did a ton of examples on this the other day, so I'm not going to spend a lot of time proving this. If you don't trust me or if you don't remember, go back to your notes. But basically, we have 3 angles that are congruent. We do not know, there's no way to prove that the 2 triangles are congruent. We don't know because we don't know anything about the side lengths. And we need to know something about the side lengths. I told you I'd sound like a broken record. I feel like I said it like 3 or 4 times on Friday about side lengths, and I'm going to say it several times today. But third angle theorem does not prove triangles are congruent. All right, any questions so far? All right. We are going to move on to my shortcuts. So I've got these shortcuts to prove that my angles are congruent. I told you that I need 3 pieces of information to be true in order for that to happen. So 4 on this side, and then there's 1 on the second page. The first one says SSS. SSS means side, side, side. If I can show that all 3 sides are congruent, then the triangles are congruent. SSS, side, side, side. So if I know that AB and DE are congruent, and I know BC and EF are congruent, and I know AC and DF are congruent, then that's enough information to prove that these triangles are congruent. They're congruent by the postulate side, side, side. So I'm going to write over here, triangles congruent by side, 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 congruent mark. On your homework, you will need to write this if that's true. So side, 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 and a congruent mark. If you don't have the congruent mark, you are wrong. So make sure that you have all those pieces. All 3 sides mean that my triangles are congruent. Questions so far? All right, next one says SAS. That stands for side, angle, side. Side, angle, side. If 2 sides in the included angle of one triangle is congruent to 2 sides in the included angle of another triangle, then the triangles are congruent. The important word in here is included, and I think that, or I remember that by knowing it means in between. So the in-between angle between the sides. If I have an angle, it's in between the 2 sides that I know are congruent. Let's look at it. If I say, I don't know, let's say AB and DE are congruent, BC and EF are congruent, then the included angle, the angle in between, is B and that's this angle in between. Whoa. the angle in between. I also think of it, if I were to trace each side, the angle that connects both sides, so it's like the heavily shaded part because it touches both sides, is angle B. Same thing over here, it's angle E. So side angle side means two sides in the included angle. So I'm going to write triangles congruent by side angle side. Any questions so far? Okay. Next, I'm going to do ASA. The last two on this page, ASA and then AAS, have the same things that are congruent, but they don't have the same order that those things are congruent. So order is important here. So ASA means it's angle, side, angle. Because side is in between the angles in my statement, that means that the side is included or in between the angles in my diagram too. So included again means in between. I could pick any angles or sides to highlight on here, but I'm going to choose to do A and D are congruent and C and F are congruent. Their included angle, or their included side, excuse me, is the side that connects the two angles. So if my angles are A and C, then the side that connects it is AC. If my angles are DF, then the side that includes it is DF. So if that's congruent, I technically now have angle, side, angle. Again, the side is in between the angles. That's what's important. So I'm going to go down here and write triangles congruent by angle, side, angle, congruence. This is similar to the one below it. So let's just jump into this one. And if you have questions, I'll answer them in a second. This one says AAS, which means it's angle, angle, side. Two angles, and this time it's a non-included side. It is not in between. It is not the side in between the two angles. There's two pictures here because there are two examples that we could see. So I'm going to use the exact same angles I used above because that means that their included side would be the same. So I'm going to look at AC and DF. Their included side, which we used above, would be AC or DF. I have to use one of the two not included sides in order for this to be true. So since there are two non-included sides, I have two pictures so you can see both of the options. Let me set up this one too while I'm at it. A and C, D and F, and then the included side I highlighted, the included side I highlighted. So we don't get to use that one. One of the sides I could use is I could use BC, EF, because those are not included. That's not the included side. That is how we read it, AAS. So that's angle, angle, side. I also could do the other side that is not included. So I just did BC and EF. I could instead do AB. That's also not included. Sorry, AB and DE. I got to do both of them. Those are also not included sides. I read this one as angle, angle, side. You have to go around the triangle. You can go clockwise, you can go counterclockwise. You could say SAA if that makes you happy, but you can't just jump around. I can't go angle, side, angle. This is one that a lot of us struggle with because you recognize it's two angles and a side, but we don't know what order it goes in. So we're gonna practice this a little bit more. The thing I think of is, does this side connect the two angles? This side does not connect the two angles. Neither does this one over here. This side does not connect the two angles, so it cannot be read as angle, side, angle. So I'm going to write here my congruent statement. Triangles are congruent by angle, angle, side congruence, or we could write side, angle, angle, whatever floats your boat. Do not care. So we just went over 4 examples. 1, 2, 3, 4. 4 shortcuts that you can use. Any questions so far?
How come you don't use like A, B, or D, E? Was that like just a choice, or is there like a rule that you
A, B, and D, E.
like for 3 or 4, or like?
I use A, B, and D, E on this one over here on 4.
Mhm.
I did not use it on 3 because it needed to be included. I also
Okay.
made this up. Like I picked the 2 angles I wanted to do, so I could have picked 2 other angles and then would have just had a different side.
Okay. Thank you.
You're welcome. Good question. Any other questions? All right, let's jump to the back. I'm gonna go over 2 examples that don't work, 1 more that does, and then we're gonna get to the pictures that look like your homework. So this question says, should there be AAA congruent postulate for triangles? Well, that kind of reminds me of what we were just talking about with third angle theorem. Does third angle theorem work? We said no. It doesn't work because we don't know anything about the side lengths. All of the examples we used had 1 or 2 or 3 sides. SSS, SAS, ASA, or AAS. They all had at least 1 S's. So no, having 3 angles is not enough information. We don't know any side lengths. Again, broken record, we don't know side lengths. And as we just saw with our 4 shortcuts, excuse me, that I just taught you, at least one of them needs to be side lengths. So I'm gonna write over here, I'm gonna say must, not could, not should, not might, must have at least 1 side length. At least 1. All of my shortcuts have at least 1 S. Some have 2, some have 3. You need at least 1. Okay? Another thing that we cannot have angle, angle, angle congruence. If you write that on your paper, you're wrong. Just like if you write on your paper, just think like, oh, that can't work, so I got to find something else, or they're just not congruent. Something else that doesn't work. You can't have ass on your paper. You can't have it written forward, ASS. You can't have it written backwards, SSA. You can't have it. It's not a congruent postulate. You can think to yourself, oh, well, it doesn't work because it's not a nice word. Well, but that's not the only reason it doesn't work. We as geometry teachers didn't get together at a big conference and was like, okay, we can't have this in here. It mathematically doesn't make sense. I've got this picture right here. If I had angle A is congruent to the other angle A, and then AB and BC are congruent to 2 other sides on the other triangle, that could make a triangle where angle C is this big obtuse angle. Or if those are the only 3 pieces of information I know, I could also have this BC rotate over here, be the same length, and make a big acute triangle where angle A and C and B are all acute angles. I have a GIF that I'll show you on Wednesday when I see you in person to kind of demonstrate this. But if all I know that angle A is congruent and AB is congruent and then BC is congruent, that doesn't give me enough information because all of those 3 statements are true in both pictures, but they are not congruent triangles. So what happens is, in addition to AAA not working, ASS does not work, and then backwards SSA also does not work. So if you want to write those on your paper, you need to realize that those are not right, and we either need to rethink or know that the triangles are not congruent. Okay. However, there is a version of that that does work, and it's called HL, and it only happens in right triangles. The H stands for hypotenuse, and the L stands for leg. And I didn't draw any pictures for you, so let me draw a picture really quick. I literally copied and pasted that, so you know that those are the same triangle. If I have a right triangle and the hypotenuse, which is the longest side across from the right angle, if the hypotenuses are congruent, and if one of the legs, whether it's like the vertical one here is congruent, or whether it's the one on the bottom are congruent, then that means that the whole triangles are congruent, and that's called HL congruency. Then the triangles are congruent. So this is the 5th one we did. Okay. We're going to skip the proof for today. We're going to do that on day 2, which will be on Wednesday. So don't cross it off, just skip it for now. But we're going to go to the back side, and we're going to do, I want to do at least 5 examples before we have to leave today. Any questions before we jump to the back and do some examples? I just got my pen caught in my hair. That's embarrassing. Okay. All right. I've got 5 back here. So let's first write down all my options. My options are side, 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 angle, side. That's 2. Angle, side, angle. Angle, angle, side. And then the last one we just talked about was HL. So those are my 5 options that I'm allowed to write on here. Let's start basic. Let's start on number 2, this one right in the middle that I just drew scribbles all over. I have AC and XZ are congruent. I have AB and XY are congruent. And I have BC and YZ are congruent. I don't have to write anything on here because all I need to know is already on my picture. This is a side, side, side congruency. All my sides are congruent to each other, so I just write SSS and I call it a day. There was no congruent marks I need to make. I didn't need to find anything else. I didn't need to justify anything. If I had to do any of those things, I'd have to write them, but I didn't here. Side, side, side. Questions so far? All right, let's go back to the first one. It's not hard, but it had a little bit more meat to it than that second one did. First off, it tells us RS and TS are congruent. Then it tells us V is the midpoint of RT. Okay, V is the midpoint of RT. That means that RV and VT are congruent to each other. They are the same length because of a midpoint, definition of midpoint. That's what it means to be a midpoint. So these segments are congruent. Now, there's one other thing that's congruent on here that I can mark. It's this segment right here, VS. I can use reflexive property to mark that as congruent. The triangles are on top of each other. They share a line. One side is VS and the other side is VS. So they're the same VS. Let me draw the pictures off to the side so you can kind of visualize what I see. Reflexive property is going to be one that we use a lot. So I'm going to label this guy RVS, and I'm going to draw the other one. Pretend they're the same. I did a kind of crappy job of tracing it, but that's okay. And this one is VST. We still know RS and TS are congruent, and we still know VR and VT are congruent. I have a VS right here, and I have a VS right there. They're the same line. Reflexive property, we're used to just saying angle A is congruent to angle A. Well, this is VS is congruent to VS. This line is congruent to that line. I have all 3 of my sides are congruent again, so I can call it side, side, side congruency. Reflexive is something that we're going to use a lot of, so you got to be ready to look out for that one. Any questions on what I've done so far? Okay. Let's do another. I'm zooming in on the 3rd one, top right corner. It says S is congruent to V. Okay, S and V are congruent. And then it says T is the midpoint of SV. So if it's the midpoint, then these segments are congruent. Again, definition of a midpoint. Does anyone see anything else that we can mark congruent that's not already marked congruent?
The vertical angles, because vertical angles are congruent.
Where are the vertical angles, Ava?
They're so they're like the ones kind of in the center.
What vertex are you looking at?
The one at T.
T, good. So there are vertical angles at T. Good, that's what I was getting at. At T, I've got these vertical angles. And as Ava just said, vertical angles are congruent. So now I've got another set of angles that are congruent. I know S and V are congruent. I know segment ST and VT are congruent. And I know that the angles at T are congruent. Which of the 5 shortcuts do I call this? Anybody?
Angle, side angle.
Angle, side, angle. Very good, Megan. I've got an angle, S. I've got a side, ST, and I've got another angle, T. So I'm going to call this angle, side, angle. The side was in between the 2 angles. Very good. Any questions on the first 3, anybody?
I just want to make sure the last one was angle, side, angle, right?
Yep.
Okay, sorry, my thing cut out.
Okay, angle, side, angle. Okay, we've got 2 more I want to do. All right, if I look at this one, this is the second one on the left-hand column. I already know that S and U are congruent, and I know the 2 angles at T are congruent. What else do I know that's congruent but's not marked yet?
RT is congruent to RT.
Good, why?
Because
A reflexive property.
reflexive.
Awesome, the reflexive property. They're congruent to itself. Reflexive property. Good job, Cece and Ava. And I'm just gonna mark it congruent. Now, this is where things can get confusing, so that's why I wanted to really make sure we got to this one today. I've got these 2 triangles, SRT and URT. If I notice that I have 2 angles and a side, so it can either be angle, angle, side, or it can be angle, side, angle. If it's angle, side, angle, then the side needs to touch both of the angles. So I'm going to ask myself, does this side touch both of the angles? If no, it can't be angle, side, angle. And if yes, it is angle, side, angle. This case, it doesn't. So since it doesn't touch both of the angles, it only touches T, it is not the included side. The included side would actually be UT and ST. That touches both S and T and both U and T. So this we call, it's not angle, side, angle, it's angle, angle, side.
Miss White, I have a question. So the last one we did, angle, side, angle, on the last problem, it couldn't be angle, angle, side. Is that because their angles are touching the side?
Yes. So on the last one we just did, number 3, the angles are touching the side. So the side is like ST, and we know S and T are the congruent angles. So that means that that is angle, side, angle. In this case, my angles, both my angles are not touching my side, so that makes it angle, angle, side. This is a common mess up, so that's why I wanted to talk about it.
Okay, thank you.
You're welcome. Any other questions? All right, last one I want to do. I know we're very close on time, but I want to look at this very quickly. On this middle one, on the second row, middle column, I've got A, B, and X, Y are congruent, and I've got A, C, and X, Z are congruent. And then I've got 2 angles that are congruent, but one is B and then one is X. If I were to label this, the ABC would go angle, side, side, which we know is wrong. And the XYZ one would go side, angle, side. Well, they don't even have the same like congruent marks. They don't match up. They're just not congruent. So not congruent is a totally acceptable answer that you may get on your homework, on a test, on a quiz. So I know I went through that one quickly, but I wanted to show you there are examples that they are not congruent. They don't have something that shows that they are congruent. Okay, for sake of time, that is all we're doing today. You do have homework due on Wednesday, and if you need any help, make sure that you talk to me about it. We're going to quiz early next week. make sure that you're staying on top of your stuff. If you need me, let me know. If not, have a good rest of your day.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.